Okay, so in 8.2.2, we're going to look more at the disk and shell method, but we're going to focus on the shell method because that's what we recently learned about. So we're going to compare the two methods first by talking about the area of this figure. So it says this is our y equals negative x minus 3 squared plus 4, restricted between 1 and 4 in the x-axis, and the line x equals 4, so it's cut off right here. So we are going to first calculate the area of this region, and this area is going to be the integral from 1 to 4 of everything under our parabola. So we'll do negative x minus 3. X minus 3 squared plus 4 dx. And if we plug that into our calculator, we'll get a nice 9 units squared. All right, then it says, imagine rotating this region around the y-axis. We're going to go ahead and sketch what that looks like. So I'll take this guy, and we're going to rotate it around the y-axis. So we'll get something that looks like this. We're going to sketch our figure, so it looks something like and then we'll have so how could I describe this figure? I don't know. It's a cylinder that's like kind of caving in here, and then we're taking out this cone-like thing out of the center, and it's getting wider at the top, looking like some kind of weird funnel guy. So we're going to calculate the volume using shells. Now, as a reminder of what shells are going to be us peeling off layers, unfolding it into a rectangle with an infinite amount of thinness, and we're going to add all those layers together, and we can represent that as one integral. So this is going to be b. So our integral is going to be our shaded region, which is going to be from 1 to 4, times our circumference, which is going to be 2 pi x. It'd be 2 pi r, but it's 2 pi x, multiplied by our parabola function. So and dx. If we evaluate that, I already did this ahead of time, so go ahead and put this in your calculator, confirm you're going to get the same answer. I wonder how many people will actually do that. I'm hoping that some of you actually do that, or try it, or even calculate it by hand, whatever. Let's go ahead and go on to the second problem. The next, we're actually going to compare the two methods and see why one of them is going to be better than the other, considering the fact we'll have to do less work. Because you notice that the method we just did with shells only requires one integral. Now, what would happen? So once again, we've got a parabola, upside down parabola, and it's going from 0 to 3. But we're going to be rotating around the line x equals negative 1 this time. So let's go ahead and sketch what this will look like. So we're going to, once again, copy over this here. Whatever, that looks good enough. Flip this guy over. And let's fix that up. So this one kind of looks like the other one that we had, except it's like got this cylinder in the center, and then like it's getting wider at the top. So imagine if we had to use washers. Now this is what A is saying. What would happen between 3 and 4? So if we use washers, this integral and this integral would be different. We'd have to use two different integrals. So the integral from here to here would be our parabola minus our cylinder, and our cylinder would just have a radius of 1. And then above it, we'd have our parabola minus our widening radius. So we'll have to use two different integrals. So using our shell method, we actually could do it with just one integral. So let's go ahead and write down an integral that represents our situation. Now, this time, I want you to imagine that just like our other previous disk and shell methods, if it's not being rotated around the x or the y axis, let's imagine that our graph is shifted over to the right. So instead of us having, so I want to imagine that our integral instead will look like this. Oh, how am I going to do this? Oh, I know what I can do. Instead will look like that. So notice that our parabola is no longer touching 3, it's actually touching 1, 3. And so instead of going to 0, 3, we're 3, 0, we're going to 4, 0. So we're shifting our parabola to the right 1 unit, which means that we need to take our function and also shift it to the right 1 unit. Luckily, this is factorable, so our function looks like negative x minus 1 squared plus 4. That is in vertex form, and if we were to shift it over 1 unit to the right, which is what we're doing, we're taking this parabola and we're going to make it look like that instead. It now has a vertex at 2, 4, which means that our new parabola is going to be, our equation is now going to be negative x minus 2 squared plus 4. And now we're ready to evaluate our integral. So we are not going to be going from, our shaded area is not from 1 to 3 this time. Our shaded area is now going to be from 1 to 4. So we're going to have the integral from 1 to 4 of 2 pi x, because that represents our circumference, multiplied by our new function, which is negative x minus 2 squared plus 4 dx. And, well, I did this equation ahead of time, so I evaluated this integral, and the end result will be 127.23 units cubed. Your homework is just going to be problem number 78. So go ahead and do that. Let me know how that goes, and I will see you later today.